Hi, hello. Can you hear me all right? Okay.
Hey, I'm good, thank you. How are you?
Good, good. How was it?
Um,
How was the day?
yeah, it's been all right.
All
Yeah.
right.
And yourself?
Yeah, I just came from Grandson to my office to have the meeting.
Ah, perfect.
Yeah.
Okay. So so this is really quick. I just want to kind of go through with you on the future fuels
Sure.
session to try and do a little bit of like technical in-depth thinking. So we need to look at understanding, like, because we only have a couple of hours, we need
Yeah.
to try and make sure that it's really well represented and we do highlight the most important things. So this could be highlighting what's Imperial's research in this area, and like specifically, maybe there's some specific research that we're doing, or overall, what are we doing in the space? But then also, we want to think about where can the collaborations between industry and academia grow? What is the most what are some of the areas where like there's going to be something that comes out of this meeting, this day, that triggers future research or puts more funding towards what we're doing. So to do that, we might need to kind of really highlight some of the technical focus that we've got, or we might need to have like a research strategy for future fuels, or maybe even look at which of these technologies or this research is likely to get industry funded. Is this something that industry would traditionally look at, or is this something that doesn't have that scope? So I think we have, so just hand over the floor to you for you to think about that, and maybe we can generate some ideas for the future fuel session.
Okay, I see. So first of all, I think the majority of the field development should be sitting in chemical engineering. So I think it's me, um, maybe only a couple of folks and Mackie who do field development. So for field synthesis, it's usually just chemical engineering, their domain expertise. So by having Nilay into part of the conversation is going to be super helpful. And I recently also spoke to Oma, who is currently the department head on chemical engineering. And I think he's going to be the upcoming dean of the faculty of engineering.
Yep.
So I spoke to him about one of the since I recently joined, and maybe there could be since now Mackie and Kemi can do together. Fuel production, fuel development is definitely one of them. But apparently we will be wearing different hats. We wouldn't be doing the exact same thing. For example, they will be focusing some electrical catalysis, so probably we will focus on the transport delivery, other parts of the story. And so first of all, this has to be combined expertise of Mackie and Cadmi in this sector, perhaps also with some input from I know of some people in Department of Materials and Department of Chemistry that might be relevant, but the biggest elephant in the room is going to be Mackie and Cadmi. So that's the first thing. So the second thing is when we speak about advanced fuels, if we think about the transport sector, I would imagine, depending on the platform we are using, we are talking about, then advanced fuels will have different implications. For example, if you talk about the let's say the aviation sector, the advanced fuels for them is apparently sustainable aviation fuel. Also, that will have different requirements, have different specifications, different categories. And if you talk about the maritime sector, depending on what other kind of shapes you're talking about, whether it's for just different depending on their size, their purposes, and there could be different ideal advanced fields for that different shape designs. And actually, right now, I'm asking one of my the recent researcher who is going to join me shortly to analyze for the maritime sector. When we talk about advanced fields, it is going to be alternative fuels like ammonia or methanol or other kinds of fuels, even nuclear, if we call that a fuel, and what is the technical readiness level for each different fuels, and what are the projected consumption of the percentages in the future. Let's say right now, maybe methanol is only, I'm just making up numbers. Maybe right now it's only 10%, but based on the base scientific evidence is predicted to grow to say 50%. So that means there's a huge growth that of interest to both the industry and also to us here, so that that can inform us what kind of directions we want to prioritize. So I just think this could be something relevant, not only to get the insights from industry, but also we can always tailor our research pathways later based on what industry is needing the most. And the basic chemistry is pretty much the same. We just want to, for my case, if we are talking about catalysis to make different fuels, the pathways, they're very much similar by mechanism, and depending on what the industry is needing the most, I can tailor my research program to, if they're interested most in ammonia, I can tailor the program to focus more on ammonia synthesis. So I guess this will be something that's going to be opportunities for co-development, so that the industry provide input, we can prioritize different directions based on the input and also based on the consensus by the field. This is just my immediate thoughts on the point. And also the other thing I wanted to mention, which could not be directly applicable, but I also brought this up when I spoke to Oma, which is what is the best way for industry and academia to work together. And speaking about that, I wanted to use the example of my recent affiliation and the MIT Climate and Sustainability Consortium. And in that one, we intentionally got initially, I think, 10-ish companies from 10 different sectors to co-define a problem about climate and sustainability together with MIT researchers. And then we identify what will be the low-hanging fruits that is of interest to several of these companies from different sectors. And then based on that, there will be tailored research pathway to tackle the specific problems that is already of interest to industry partners from day one. There will be mechanism with for example, seed fund by the industry, and the IP will still be owned by the institution. And moving forward, they can, based on the results of the seed fund, there's also opportunities for the industry to invest bigger amount of money to dedicated research themes that is of interest to them, and whatever research output from that, the view made available to the industry partners and sponsors, and they will also have the priority to license technology if that come to an interesting result at a later stage. This could be, so I spoke to Omar about the consortium, and he, considering his upcoming role as the dean, he's very interested in seeing how we can potentially maybe use sustainability as a pillar to gather different industry partners, potentially do the same thing here and in Pure as well. But anyway, this is just very early stage of discussion. I'm just thinking about maybe, since you talk about the collaboration space. Maybe this could be something we could use, and the VFH we can also do. But anyway, just similar of the immediate thoughts here.
Yeah,
I'm
I
happy
think
to chat
that's
more.
a really, I think that's a really like great idea, and it's definitely something that we have been thinking about as well, because the original plan that, well, there were a few plans, but one of the plans that Greg had for this day was to have some sort of like brainstorming meetings. And it could be, for example, we could decide in this session for Future Fuels that on the Friday after, there is a more detailed like workshop with a few collaborative partners who are willing to kind of go into a bit more detail with a few academics to really do some sort of brainstorm, as you pointed out, like maybe some kind of like co-design workshop. That's also possible. So we could trial it, see how it works on a small scale, and or so there are definitely opportunities for that. I think it's a really important one for us to think about. So on the sustainable fuels or future fuels, so yeah, I agree. I think getting Nile in this conversation would be really useful. So maybe if I put together a call with yourself, Nile, and myself to think a little bit about that, maybe see where ChemEng expertise can come in handy on what we need to cover. I think we're going to stay clear of aviation fuels just because that's Bramwell, but we can cover maritime. We can cover heavy duty sectors or off-road. I think.
And quick question here. So when we speak about future fuels, are we only thinking about the production, and what about the transportation? So what different processes are we thinking about here?
Oh, I think it's all kind of relevant.
Okay.
So when we talk, I think future fuels is a opportunity area.
Yep.
And the Vehicle Futures Hub is interested in looking at how do we contribute research to this opportunity area based on the capabilities we have at Imperial. So so I think if transporting fuels is an important problem, then we should be looking at transporting fuels. And if we have the capacity as well and the research expertise on that, we should definitely be looking at it.
Because my expertise is on the production end, but for certain fuels, you probably need to think about transportation and storage. But for my specific expertise, that's not my area, so I couldn't really comment on the transportation needs. Are they really very mature process? But again, it really depends on what kind of fuels are we talking about. So we really need to, do we at a point want to narrow down, for example, do some case studies, say, because if you don't define what the application is, it's really difficult to, narrow down to what kind of fuels you're talking about.
So I think because the stream is maritime fuels and heavy duty.
Oh yeah, it's all together. Yeah.
Yeah. So you've got those. One of them will be road vehicles, and one of them will be ships. So that gives us 2 case studies. I suppose. Okay, so maybe we don't quite have enough information as yet to be able to understand what is the technical scope, but perhaps maybe a separate but related question is sort of where is your research going? Like, what would be important for you to be able to grow your area, and also maybe just the general fuels area or the energy and emissions area of the hub, because that is an area we can think about as where are we now, where do we want to go, and what's going to help us get there.
I see. So for my own research program, I in the past I use solar to produce fuels, to convert solar energy into fused chemical energy, and I combine the photon energy and also the thermal energy within the solar spectrum to do that. And moving forward, I'm very interested in seeing other different processes potentially also driven by renewables to produce fuels. And to that end, my immediate research interests include combining photo with microwave and also photo with plasmonic and other energy carriers to enhance the fuel production efficiency. Because in my previous research, I do recognize if you only rely on a certain energy carrier, the fuel production efficiency is not high. But if you combine different energy carriers like photo, heat, wattage, ultrasonic, you can have synergistic effects by combining this together. So this will be something very interesting in exploring. And to that end, how when you combine different energy carriers, what is the transport and delivery of these energy carriers, and what is the co-design of these different device architecture, and what you need to think about on a system point of view. So that's a multi-scale design and optimization problem that's related to fuel production that I want to pursue further. And on a related topic, what is ingredients you use to produce these fuels? This is also something I think very interesting to explore. So traditionally, for example, if you talk about making fuels from, let's say, using CO2 as the ingredient, where do you get that CO2? Are you getting that CO2 from the gas cylinder, or are you getting CO2 directly from the air, or from the ocean, or from the exhaust system of vehicles? So that, depending on where the carbon is coming from, you need to tailor the design of your processes. For example, for certain processes, you have a lot of impurities, and how do you design a process and materials to be tolerant to these impurities so that these materials they don't get poisoned? And if a lot of the cases when you want to enhance the production for fuels, let's say if you use CO2 as an ingredient, you need to bring another co-reactant. Many of the cases for the mature process, you need to think about hydrogen as another reactant so that you can produce, let's say, methanol or other fuels, or syngas, which is a carbon monoxide and hydrogen. But hydrogen itself as a reactant, if you rely on traditional methods to make hydrogen, it doesn't make a lot of sense. Essentially, you're burning a lot of fossil fuels to make the hydrogen, and then using hydrogen as ingredient to make the fuels. So this, if you do life cycle analysis, this doesn't make sense. You are still emitting CO2. So first of all, thinking about where all the reactants come from when you make advanced fuels. This is, I think, something would be very important if you think about the eventual goal is to be net zero and potentially, I don't think there's a clear pathway to be carbon negative, but carbon neutral is the best scenario we can achieve with advanced fuels. Eventually, you have to burn that, and if you can capture every cent of the emitted CO2, and if you can convert everything into the fuels again, the best scenario will be net zero, and right now we are still falling really short from net zero. So how do you combine different energy carriers to accelerate the efficiency of conversion? This is the one research topic I'm interested in. And the other one is, how do you think about sustainable ingredient to make these advanced fuels, potentially using some of the captured CO2 from the combustion process in a later stage, so that you will have an interconnected research program of carbon capture and carbon conversion, so that you can have a system as a cycle to reach net zero. So that's, I think, my two research directions are going. One is about the synergistic effects of multiple energy carrier for fuel production. The other one is sustainable ingredients to making the fuels by potentially using the captured CO2 or other sources.
Okay. All right. That's really useful to know. And so the other question I had. Okay. So based on this, what at the level of research that you're at, what industries are interested in this work? Or like, do you know any industry players that you can think of?
Let me see. So since I'm producing fuels, so whatever industry that's using fuels, I think it will be of potential interest. So definitely, the people who develop the shapes, and if they have a target to be net zero, that would be the potential partners to potentially sponsor the fuel production business. And on the other end, the carbon capture part, I do know. So for the sector, they're already talking about onboard carbon capture, and I used also do consulting for partners like. So there's actually companies like 1.5, which is a US based company, that is a dual air capture company, but they're also exploring opportunities to design modular capture units for the maritime sector. And so the potential, I think, partners that would be interested in this is pretty generic actually. I would envision they all need to consume fuels in the future, but we also want to be strategic in identifying who is going to be the biggest player. And I guess right now I don't have the immediate names, but I think maybe I can do a big more research into the company names, especially in a UK context, and then we can move from there.
So you potentially, when we talk about future fuels, you might also want to include like carbon capture companies. Okay.
So I do carbon capture research as well. I probably don't need to partner with a company that does carbon capture. I just wanted to find perhaps, let's say, for the maritime sector, what other major companies making the ships in the UK. I'll be very interested in speaking to them, because if it's, first of all, the ships will consume fuels, my advanced fuels will be potentially of relevance to them. And secondly, by integrating carbon capture units with different ship designs, that requires the academia and industry to work together to co-design what's going to be the next generation of the future ships that we can incorporate onboard carbon capture, depending on their need. For example, what is their available space on the ships, and what other available energy resources we can use on that ship, so that based on their requirement, we can design the tailored onboard carbon capture units. And I think that's always better if we can get involved in seeing what is their current status, so that we can design the technology based on their needs. For example, if you think about energy resources, there will be some, I think, waste energy on the ship, and we can easily design some thermodynamic systems, for example, based on organic Rankine cycles, to utilize the waste heat. And by utilizing this waste heat, we can potentially use them to power the carbon capture units. And the heat grade, the energy grade for the waste heat wouldn't be high. That meaning the temperature range of the waste heat in the ships wouldn't be 900 Celsius. But perhaps we can use this low temperature waste heat to power some solid solvent based carbon capture technologies. So really depending on what is available there, we can think about what is the carbon capture technology we really want to couple with that specific ship. Because carbon capture is also pretty broad technology. You think about different temperature ranges and different requirements for space, and among others. And by having a good knowledge on what is currently available, we can think about what is the best way we can couple the most mature technology based on their requirement. That's something I think we really lack some knowledge on the point. But I would think it would be a very interesting opportunity in developing the next generation of net zero ship designs.
Okay. Right. So all right. So next steps, I think get in touch with Nile
Yep.
to try and understand what can we cover in this. So maritime, because we've got maritime session anyway, like it's going to be like maritime fuels, heavy duty, like all together. So that's like an interesting mix. Everybody in that room will be interested in in similar things. So just so I can make sure we've covered it, in terms of the industry audience, there will be maritime people, but who else? So I think you mentioned DNV already before.
Mm-hmm.
Who else should we be inviting? So, Shell, Johnson Matthey, who else?
So should we also think about some government agencies? And so let's see. I recently came across a call, and just give me one sec. Oh, how do I minimize my page? Okay, just give me one sec. I just wanted to throw a couple of names. Okay. Okay. So, can I share my screen?
Mm-hmm.
Okay. So so previously I listed something, and I think will be potentially relevant. Here, can you see my screen?
Yes. Okay.
Yeah. So this is during my job talk in Imperial. So I talk about the potential industry sponsors. So Shell, definitely, I think Shell has a huge interest in advanced fuels, and we have this center and Imperial. And here also listed, so we are not talking about aviation, so let's just move, let's don't talk about British Airlines. But this will be potential of relevance here. There's the Port of London Authority, and especially they have the Net Zero River Plan and the Maritime Hydrogen Highway. So I'm not sure. I think part of the government agency here, but looks like they are local. Potentially we can take a further look into this. And there's another one, I think it is for the UK in general, than for the automobile sector, then they have the advanced propulsion center. And so fuels, I think, will potentially be of relevance to them as well. And and since we are talking about fuels, transportation, I was wondering, is there anyone from the Department for Transport we can potentially reach out to? Do we have existing connections?
We did invite somebody from. We actually did a maritime roundtable earlier this year.
Okay.
This was before you joined, and we had someone from DFT, Matthew Ball, who was the head of the UK Shore our program, who came, who I will invite again for this day. And then we do have a list of names from DFT that I've found from Imperial's policy team. And so the person who's helped me find this, her name is Rosie Allen. And so she's put together a list of people in DFT working in maritime. So that's Deputy Director of Maritime Decarbonisation, the Deputy Director of Ports and Shipping, Deputy Director of Hydrogen Strategy and Portfolio. So we could, that's in DESNAS. So we could, if we think that it's going to be really important to have them in the room, we could definitely reach out to them as well. As well as, so I don't have any contacts at the Port of London Authority, but we can check if Imperial has any contacts here.
And also regarding DFT, they have the Advanced Fuels Fund. I was just wondering, have they already allocated and decided the winners for, let's say, initial cohorts or in their announcements? If they do, can we reach out to, several of the potential awardees as part, because they apparently are interested in advanced fuels? And also, DFT has this clean maritime demonstration competition. I'm not sure whether they announced the winners, and if they do, the people who win this could definitely be relevant. Just thinking about for the relevant programs that DFT is already sponsoring, based on that announcement, that could lead us to more places and more people, potentially some startup companies or some other players that we already know they are interested in this sector. So that's just another idea.
Yeah, so from that then, this is the list of the competition winners from, so this was 2025. I don't know if there's a new, there's a bunch of people that might be interesting. So
I see.
These are small companies. So this is the advanced fuel competition companies. Yeah.
But the money is a lot. It's some, I think some companies get 6 million. Wow.
I know.
That's a lot of money.
Equinor is a big.
Yeah.
That's interesting.
Yeah, Equinor is big.
Yeah, I thought Equinor's big, but Equinor Low Carb in the UK, I think, is a separate subsidy, maybe.
Oh, okay. And LanzaTech.
I recognise one name, which is Zero Petroleum, which is from Imperial.
I see.
I don't know if any of these other ones are. So, okay, we can even float this to Nile, because Nile might know which of these people is interesting for us to try and invite.
Yeah, there are many names based on list.
So yeah, the 17 companies were awarded. Well, no, that's sustainable aviation fuel was. I think that was the same.
Yeah, I think they say they have the potential to produce stuff. But the principle should be similar. It's very easy for the companies to develop other advanced fuels.
exactly. Yeah. So
Yeah, that's the same.
there's
Yeah. Mm-hmm.
there's all of these 63 million's a lot, so hopefully that some of them have made some money to do other things. And yeah, so I mean, Ricardo did I think Ricardo UK did the guidance for it. This is very much my old job. Okay. Right. Okay. I'm gonna.
So what about the clean maritime demonstration competition? So that one, I just find something. That's a funding opportunity. Okay, wow, that's a lot of money. I just put it here. That's 121 million. Wow. And they have the winners. Okay, they have the winners here as well in this link. They already they already had the round 6 winners.
Round 6. So that was last year.
Let me check.
Yeah, interesting.
And when I check the winner list, for example, okay, if you click, how do I? So for the second link, if you just click the first document, which leads you to there's gonna be Excel sheet, and the Excel sheet talks about the project names and organizations for the different projects. And when I just checked, just do a very quick check, for the organizations is usually a combination of academic institutions and companies. The first one, they have the University of Birmingham and and another university, and also several and 3 companies. This could be one of the ways the industry and academia can work together, because this is already showing a good mechanism already funded as the maritime demonstration competition winners. And similarly, maybe for fields or others, we can perhaps do similar things to target some larger government grants.
Yeah. Okay. So basically what we might do on the day, because we are thinking of doing this anyway, is kind of look at open opportunities, highlight some opportunities, like highlight funding opportunities. For join. But I suppose what might be very important here is what is distinctive about Imperial's expertise. That is, why go to Imperial? What's different about here as opposed to Manchester or Coventry or, I don't know, Exeter on this space? And that's what I want to pull out in this session. So, like, if it's going to be, for example, fuel synthesis using novel solar thermal, techniques, if that's unique to Imperial and it's interesting, then that's something we need to highlight, because you won't get that anywhere else. That's exactly the kind of pull, because yes, they can work with universities, but they can work with any universities. And I think our job for this day, just to be a little bit selfish, is to be like, no, but work with us. So I think that's something we really need to bring out in this session, as well as the other sessions, but definitely this session, because traditionally maritime and fuels, it has been covered quite extensively by other universities because of the usually just geographical benefits. So maritime, like mostly like Southampton, Portsmouth, like those universities have been really, really good just because they're based by the sea.
I see.
But you're right. We do have the advantage of being in London, which gives us that Port of London Authority, which is really interesting. Often they work with UCL. So where does Imperial have its say? So yeah, I would be keen to kind of really understand what do we see ourselves doing more work in? Like, where do we see ourselves growing our expertise in the space? Now, one of the things I think is fuel synthesis.
Yep.
But then I think there's another expertise in mech-eng which we definitely should try and highlight, which is the engine combustion, burning, like that side of things. And that's Pavlos. Have you met Pavlos?
We don't have time to we ran to each other, but we didn't have time to have in-depth conversation yet.
Yeah, so I think we should ask Pavlos, and because they actually will be very relevant to the heavy duty side of things as well. So like the use, like how do we use these fuels? Is there a difference in their combustion strategy?
Yeah, absolutely.
Okay, so. But I don't know if that's been covered anywhere else, but I definitely feel like if that's an area we could grow. So, okay, in the interest of time, like some next steps.
Yep.
Like I'll reach out to Nile and ask for a call. I will reach out to Pavlos, Alex, Yanis, for combustion support. Combustion, what do we need to highlight in combustion? Nile, and then we're meeting on Friday anyway, but I think let's see what happens in this time. If we manage to get some conversations, that would be really great. So it gives us a bit more clarity. And yeah, whenever if you take this away with you as well and think about what is really nice to highlight here, which is Imperial specific, where we can kind of really show, it's the showcase part, like come and work with Imperial on this technology because we are the experts. That would be really good to know. And it could be your own, it could be the research you're doing, but it could also be research that other people are doing in the department as well.
Yeah, absolutely. So we should prioritize on what we can offer from MECE and potentially some from ChemE, right? Are we on the same page?
Yeah, I think definitely. So I'm going to reach out to Nile. I will CC you as well.
Yeah, that would be helpful.
So that will be the ChemEng link to this. And then mech-eng, it's less fuel synthesis, but more like use and, engine optimization kind of thing. But transporting fuels, like the enclosures, the casings, the safety concerns, the material testing, I do wonder if that's something that we should kind of show in our overview, because we do have capabilities for like material inspections, like, I don't know, corrosion, like hydrogen perceptibility, that kind of thing, where material optimization might also be relevant for future fuels. So yeah.
Yeah,
I
that
don't
definitely
know.
could be relevant. I'm just not sure about what is the magnitude of a problem we are talking about. If it's just a very minor problem, perhaps we, for the sake of time, we can just neglect that. But if it's going to be a very significant bottleneck in the future, we definitely want to consider that. And just something I'm not aware of yet. If this is a real problem, then that's our opportunity. Speaking about the unique expertise and advantage of Imperial, so we just say, Mackie, Academy. But what about other things that happening at Imperial that could be relevant to the fields? For example, there's a colleague who I know of, and the Center for Environmental Policy, and I'm not sure whether you know him, Niall McDover. His expertise is on doing the evaluation, techno-economic analysis, and also life cycle assessment for different energy-related technologies. He is very big in carbon capture, CCUS. So part of the CCUS is carbon conversion that could be relevant to fuel production. So if we limit ourselves to Mackie, Cadmi, so he wouldn't be included in this. But if you look at the whole landscape about Imperial, we also have the business school. Potentially, there are better people there who can evaluate from the business point of view. So we don't have. So I just wanted to think about what is happening beyond Mackie and Cami. Perhaps someone from Center for Environmental Policy may be helpful.
Yeah. So Faculty of Natural Sciences. So that's just it's not in the Faculty of Engineering, but definitely I think if we do have relevant work at Imperial, I do think it's important for us to kind of highlight the relevant work. So and okay, so and business as well. So
yeah, business as well.
And then
maybe not medicine, because medicine wouldn't be that relevant.
But maybe afterwards.
Yeah, maybe afterwards. Yeah, but I definitely think
issues.
Yeah. So also speak of another irrelevant stuff. So I'm actually recently started some conversation with a person in Department of Life Sciences with expertise in protein engineering. So I was trying to see how I can combine light and protein engineering together to develop some light-driven leaven systems to capture carbon in time and potentially also deal with the conversion. So even for academic research point of view, there are people trying to talk about the biohybrid systems for fuel production, for carbon capture. So I think that will create new exciting opportunities. Saying, Imperial is very strong in engineering and science, and so there's opportunity to leverage our connections and expertise of our colleagues within the other side of the other faculty, so that we can develop a program together. And in Department of Chemistry, there are a lot of people work on photocatalysis. So I think that would be something. And also even in Department of Physics, I recently spoke to several colleagues there. They are very experienced in photovoltaic, among others, that could be relevant to producing fuels at a later stage. I know some of them are already collaborating with chemical engineering for fuel production, water splitting to produce hydrogen. And so I think maybe if it makes sense, we can highlight Imperial. It's a STEM B school, so we can combine the unique advantages of our basic fundamental science to the engineering part, and so then we can enhance the full value chain of the production.
Yeah, and I think that's a fantastic idea. Actually, I think maybe that's a really nice overview talk I think an overview of the landscape of like what do we have, and then maybe we can go into some detailed like talks later, but I think that overview landscape will be really useful, and potentially if you could give that talk.
Yeah, so I think we can so speaking about the talk, we can have something like, I think some slides linking these three different faculties, from faculty of science to faculty of engineering to faculty of business, each work on a different end of the story related to let's say fuel production as an example. We can showcase why Imperial is unique, because we have this different academic staff sitting in the different faculty, and we can work together for the same problem, offering different lenses, different perspectives. And that's maybe something that's compelling, that other institutions, they wouldn't be able to have these comprehensive skill sets sitting around the same campus.
Yeah, okay, that's a nice, so I'll put that down as a potential, for us to discuss on Friday.
I think it's Friday,
so,
right?
Yeah. So we could, so we could do, for example, like an overview of the future fuels.
And we can list several
landscape.
departments, even several research groups, if that's relevant, and showcasing the collaboration is already happening. I know of, for example, a faculty and a professor in Department of Physics is already collaborating with a professor at chemical engineering, and they two have a Nature Energy paper together talking about fuel production. So that's already some successful examples to showcase this is already working. And by having this hub, we want to maximize the impact. Then we can make more connections to work on the same topic, and that we can create more opportunities to leverage this to apply for some bigger grants in the future.
Yeah, exactly. Right, perfect. So, okay, I will digest this. I will get back to you. I will see you on Friday.
Yep.
If you've got more thoughts, feel free to email them to me. But yeah, I think a good starting to kind of shape up. On Friday, I'm going to try and focus on like who do we want, like more specifically, who should we send an email to as maybe a speaker or a panelist. So if there's somebody in each like session, if you've got somebody in mind, please do kind of keep that in your head, and then we can discuss it on Friday.
Yeah, absolutely. And I can already send you one of the names, and whose name is Salva. He goes by Salva, I think. Not sure whether you came across this name previously. It's part of the Department of Chemical Engineering. I had a one-on-one with him previously. And he's the person I talk about. He had a Nature Energy paper with Professor, I think first name is called Jenny, not sure about last name, Jenny Nelson, and that's Department of Physics, and they two collaborate and leading to some very impactful work in advanced fuels production. Just one of the many examples that we could possibly imagine. Just wanted to, but I recently had one-on-one with both of them, so I know they are working on something together. And he's sitting across two faculties, so that's a good example.
Yeah. Okay, perfect. Right. Yeah, if you've got external speakers as well. So if you can think about external panelists or external talks. Okay, awesome. I'm going to have to go for another meeting.
Sure. And let's meet up again on Friday. And this is the link to the paper they work together.
Fantastic. So they can give an overview of the paper. So
yeah, and that's very impactful paper. One of the top journals in energy field, Nature Energy, just published last year, very recent as well.
Yeah, perfect. Okay, it's great.
All right.
All right.
Yeah,
Let's speak again.
Take care.